this video, we're going to have a look at expanding expressions. To begin, let's consider a number situation. Imagine we're asked to calculate mentally 4 multiplied by, in brackets, 20 plus 6. So essentially in this question, they're asking us for 4 groups of, in brackets, 20 plus 6. So what I've got are my 4 groups of 20 plus 6. So when we look at this situation, essentially what we've got here is our 4 lots of 20 and our 4 lots of 6. We can see that here, 4 lots of 20. When we consider our original question, essentially we've said 4 multiplied by 20. And to get our 4 lots of 6, we've said 4 multiplied by this positive 6. And we can work out that 4 lots of 20 is 80 and 4 lots of 6 is 24, and we get an answer of 104. So essentially in that question, what they've asked us to do is remove those brackets by distributing that 4 into every term inside those brackets, the distributive property. So 4 multiplied by the 20 and 4 multiplied by the positive 6. So would this work when we use variables? So let's take a look at another situation. Let's consider expanding 3 multiplied by, in brackets, a plus 4. So again, essentially they're saying we want 3 groups of a plus 4. So I've got my 3 groups of a plus 4. And here I've got my 3 lots of a. And I can see that's 3 multiplied by a. Now I've got my 3 lots of 4, which is 3 multiplied by positive 4. So we can see, in essence, when we've got our 3 multiplied by a, we've got 3a, and our 3 multiplied by 4, we've got our positive 12. So another example would be to expand 2 multiplied by p minus 5. So here we can say, well, we want 2 multiplied by the p, which will give us 2p. And then we want 2 multiplied by negative 5. Remember, the sign in front defines that number. So 2 times negative 5 would be negative 10. And there we've expanded this expression and removed those brackets. We can also look at this from an area perspective. So let's imagine we have a rectangle that has a length of 5 and a width of a plus 10. We can see that across the top of our rectangle. So Dan wanted to determine an expression for the area of the rectangle shown on the right. So he wrote the expression for the area as 5a plus 50. So can we see where he got this 5a plus 50 from? Well, thinking about how we find area, he's actually looked at the very first rectangle. We'll call this rectangle 1. And he said length of 5 times width of a, the area of the first rectangle is 5a. And then he's taken the second rectangle, we'll call it rectangle 2, and he said the length of 5 and the width of 10, and this gives us a total area of 50. So we can clearly see where Dan got his expression of 5a plus 50 from. If we use the idea of area being length times width, we can look at another way of writing this expression for area. Let's consider the whole rectangle. So, if we have a look, we would say that the area of this is going to be 5, the length, multiplied by a plus 10. We can put that a plus 10 in brackets because that represents our width that we want. So if we expand this, so we've got 5 lots of a, first term in the bracket, and 5 lots of positive 10, that would give us our 5a plus 50. So our expression here of 5 in brackets a plus 10 essentially is equivalent to Dan's. These are called equivalent expressions. So in this example, we're using area to write an expression that involves these brackets. So now we've got a bit of background of what it means to expand an expression, essentially to remove those brackets. Let's have a little bit of practice. So often we're asked to expand and then, if needed, simplify. Our first question is 5 in brackets t plus 8. So we begin with 5 multiplied by our t. We end up with our 5t, and then we've got our 5 multiplied by our positive 8, and that will give us positive 40. Now 5t and positive 40 are not like terms, so we're not going to put them together. Our second example is 3 multiplied by, in brackets, p minus 4. So we begin again with 3 lots of p, which will give us 3p, and then we've got our 3 multiplied by our negative 4. 3 times negative 4 is negative 12. And that is how we end up with that subtract sign, because the value here is negative 12. Our third example is 4 multiplied by, in brackets, 2d plus 1. So once again, 4 multiplied by 2d is going to be 8d. And 4 multiplied by positive 1 is just positive 4. In our fourth example, we have a negative number in front of the bracket. So we treat this exactly the same, we just be careful with our negatives. So to start with, we're going to have negative 5 times 6a, or negative 5 times 6 is negative 30a. And negative 5 times a negative 1, so be careful here, is going to be positive 5. So once again, negative 30a and the positive 5 are not like terms, so we're not going to combine them. In our final example, a slightly different expression, we're going to first concentrate on our bracket, removing that bracket by expanding. As BIMDAS says, we must do that first before we add another term. So beginning 2 times y being 2y, and 2 times negative 4 is negative 8. Now we're just going to write in that plus 5y on the end because we have not used it yet. Now in this example, we can very clearly see that we've got some like terms. We've got this 2y, positive 2y, and a positive 5y. So we can put these together to say 7y. And then, of course, we've got our subtract 8, our negative 8, which is still there. Again, we're not going to put these two terms together because they are not like. So hopefully you found this video helpful in understanding how we expand expressions and how it applies to area. So now it's your turn. I'd like you to complete the following 5 questions. The first 4 questions ask you to expand the expression by removing the brackets and then simplifying by collecting any like terms where necessary. In question 5, you are asked to state an expression for the area and the perimeter of the following rectangle that you see. It's the solid black line that is the whole rectangle. You pause the video and have a go, and then you can come back and check your solutions. And here are the solutions.